Welcome back to the classroom. My name is Mr. Wong. We are back at it at an explain exam question session. Today we're going to be looking at the 2015 HSC paper, and we are going to be looking at explaining how emission spectra and absorption spectra are produced by specific celestial objects. Okay. So obviously, if we're talking about explain, we need to show cause and effect. We need to discuss about how the features of the formations of the emission spectra and also the features of formation for the absorption spectra. And specifically, we need to connect this back to celestial objects. And well, in this case, that could be stars in the universe or anything like that. What we can do firstly is probably draw an annotated diagram of the two. So if we have emission spectra here, and on the other side we'll have absorption spectra. So just before I do that, I might just quickly draw out some values. Okay, and then in a different color, I'm going to draw out my absorption spectra. So we have absorption spectra. You could do it on the same one. I just find that potentially this might be a little bit more clear for those who don't usually draw diagrams for the exam papers. Okay, so with, well, the way it works, it's all about the electron, right? So we have, let's say for the absorption spectra, we have an electron in a low energy level, and it absorbs, and then we have a photon, so we have a photon of a specific energy that is absorbed by the electron, and it goes all the way to number 4. Okay, so level 4. And now what we know is that the energy difference, or the energy of the photon, just so happens to be the energy gap difference between our energy 4 by our energy, or energy 2 by our energy 4 there. That's the difference that allows us to jump up to that category there. In another scenario, let's say we have an electron on energy level 4 and it pops down to energy level 2. In that process, energy in the form of a photon is being emitted. That photon's energy is equal to the energy gap between these 2 points. So the final point we got was final destination was level 2, and then subtracted by the initial destination, which is 4, which means that this should have been 4, this should have been 2. My apologies. Okay, so that's what we have there. So let's actually try and explain how this forms. Firstly, we need to note that each energy level of electron shells are quantized. Okay, so that's what we have there. What that essentially means is to shift between shells, energy must be absorbed or released, and the key point is equivalence. So it needs to be equivalent. Hopefully I spelled that. I don't think I spelled that right, but doesn't matter. Equivalent to the energy gap the electron moves to. Okay, So remember, electron shells are quantized. The energy has to be at that specific range to take it up to that specific value. If by chance we have a photon that strikes it, but the energy provided is within the gaps of the energy shells, then obviously there's no transition, because energy or the shells are quantized in this state. It's like you try and jump halfway through the stairwell. It doesn't work that way. So that's what we get there. Okay, so that's what we have. What you can also see in this case is that emission and absorption spectra are basically the opposites to each other. All right, so emission spectra. Oops. So the emission spectra is opposite of the absorption spectra in terms of its formation. So that's kind of the thing that we have here. We've explained how it's formed. Okay, so what we have here, so in order for the electron to move from here to here, it has to have lost energy. So energy must be lost by electron to shift down. And then on the other side, for our electron here, we need to have energy must be absorbed in order for electron to shift up the levels. And that's really the main difference between the two. One needs to absorb electromagnetic radiation or absorb energy to go up. The other needs to release energy in order to come down. I guess the last bit we can talk about is where in the universe we expect to see the formation of absorption and emission spectra. So maybe I'll just get rid of this part here in terms of the how. So we've explained the actual formation. Let's go through the actual how, or where can we see this happen. So for absorption spectra, it forms when the gas molecules in the sun's atmosphere absorb electromagnetic radiation from that was emitted from the sun's core. And then obviously the next one we have is emission spectra. Now emission spectra, you can see it in terms of different nebulas, different types of excitations as well. So what we can say is from the electrons relaxation to move back into a low energy level, electromagnetic radiation is released, forming the emission spectra. Okay, so that's how you answer the question. Hopefully you found that useful, particularly all these little colors. It's quite colorful, I must admit myself. So that's explaining a cause and effect relationship of how one is formed and how the other is formed. And then obviously what we've done at the same time is look at specific celestial bodies, link that back up all to the question. So that's how you would answer the question to get full marks. Obviously there might be some points that you want to pick and choose to take from. To get full marks, you could just do an entire diagram and then a little note like this at the end, but this diagram does give a nice depiction of the difference in their formations. So hopefully you found that useful. I'll be doing a bit more exam explain videos later on, but if you need a bit more revision on emission and absorption spectra, do have a look back at the old videos from Module 7 or Module 8. Anyhow, take care.